Section 9.4 is on the area of composite shapes. So our objective for today is to accurately calculate the area of composite, which means multiple polygons together, shapes. So compound area problems. Some shapes don't have a neat little formula that we can use to calculate the area. And sometimes we are going to have to figure out a different way to calculate the area. Hopefully we're able to do this accurately without having to round or estimate. And for today's homework problems, you're going to be able to get exact answers. Sometimes though, in real life, you're going to have to estimate some measurements because not all shapes are easily able to find the area of. So for example, if we were given this shape as a problem and we were told to find the area, the first thing we're going to want to do is divide it into two shapes where we are able to find the area of the objects. And we've done this before a few different times in our homework problems, so hopefully this isn't brand new to you. So now we're going to have two different shapes. We have shape 1 and then we have shape 2. So to find the total area, we're going to find the area of shape 1 and we're going to add that to the area of shape 2. So for this one, we have a rectangle. And to find the area of a rectangle, we take the base times the height. And this one, or length times width, we have 4 for a length and the width of 5. So to find the area of that shape, we're going to take 4 times 5. And then we have to find the area of this triangle. And remember, the area of a triangle is 1/2 base times height. So let's see what information we know. We know this full length on the bottom of this shape is equal to 7 inches. And the first shape we know is a rectangle, which means the opposite sides are congruent to each other, meaning this section here is 4 inches. So out of the 7 inches, there's only 3 left to be the length of the base of our triangle. And then on our height of our triangle, we know this section of the rectangle is equal to 3 inches, which if we were to draw a horizontal line over here, would mean that it would be 3 of 5 inches in total, because again, opposite sides of rectangles are congruent, which would make this 2 inches. So now we can find the area of our triangle, which would be 1/2 the length of the base times the height. And now we have enough information to calculate the area of this shape, which would be 20 plus 3. So the area of this shape is 23 inches. And you'll see that if you work through this problem, that you would get the same thing as you read through the steps that they took. The next type of problem that we are going to encounter today is finding the area of a shaded region. So in order to do that, we're going to first find the area of the outside region. So the bigger object in this case. So the area of this shape, it is a square, is going to be 3 squared. And then to find the area of just the shaded region, we are going to subtract the area of the non-shaded region. And sometimes there's going to be multiple areas we're subtracting, but in this example, there's only going to be one. And because that's also a square, we're going to be multiplying 2 squared. And once we do that, we're able to find the total area of just the shaded region, which would be 5 centimeters squared. These are the things that you're going to be working on today on the homework. If you have any questions, just let me know. And if you get stuck on a problem, feel free to look at the answer key to see how the shape was divided up in order for it to be possible to find the area. And if you have any